Hello, my friends. Today we're going to talk about source. As you saw in previous episodes, they are very applicative. You must have source function in any system in order to enter the input to your model. I begin with in block. It's about subsystems. The signal enters with an in block in the subsystem and exit with an out block, which we will talk about these signals in subsystem chapter. The next block is ground. It's similar to terminator. We connect the terminator to the outputs of useless blocks, but we connected ground to inputs that we do not want to use them now. Using these blocks prevents MATLAB error or on disconnected blocks. The Simulink makes error, as you know, on any port which is without any destination or origin. The other block is from file. It's similar to toFile. We could change the file to .mat by toFile, but here we can call a file from .mat. Also, there's from workspace here. I try to focus on the new blocks more. The other blocks which I want to explain here is signal generator. We have used it many times before, as you know. But we just used it for sinus signals. In this block, there are many variables. One is waveform, we should specify. Waveform specifies the function which is located here. We set its amplitude here and frequency here and time here. We define the waveform here. As you see, we have 4 waveforms: sine, sinus, square, sawtooth, and random, that you can use all of them. Here we can determine the time, which either use Simulink simulation time or from external sources which enter with clock. But because we often have the time in Simulink, so we use simulation time. We can set the amplitude and frequency values here and also define the frequency in hertz or radian second. I want to show you the 4 signals of signal generator in order to get them know better. I use a scope with 4 inputs. I want to show the 4 signals using this block, so I get 4 copies. 4 signals should be entered to the scope. I change its number of axes to 4. Like this, I connect them to each other. In the first signal generator, I set the waveform sinus and don't change its amplitude, but change its frequency and set it 0.2 hertz. In the second signal generator, I set the waveform square. In the third signal generator, I set the waveform sawtooth, and in the last signal generator, I set the waveform random. Now I click on the scope and I can see the waveform of each function. Our first function was a sinus wave with frequency 0.2 Hz. The second one was a square wave, and the third was a sawtooth function. If you change the frequency, sawtooth form will be changed, and if change the amplitude, its maximum value will be changed, and we have a random signal here. that changes from -1 and 1 with frequency of 0.2 Hertz. When we specify the frequency, these levels will be indicated. I save this model as signal generator. Okay, like this. It was the first source block which we looked at it. The next block is pulse generator. It generates a pulse signal. Okay, as we can see here, I get scope. I connect them to each other. Zoom in, and as you can see, there are two options for pulse time-based and sample-based. I choose time-based, then I choose use simulation time. You can set amplitude and pulse period. I set it 1 and set pulse with 1, 2. Also, we have phase delay, which you can set delay for your destination. Now I run it. And as you can see, here there are pulses which have been generated. Here you can generate your pulse in any form by pulse generator. The next block, which is very, very important, is signal builder. This block generates all the mathematically difficult signals. Consider, for example, an output which its modeling is mathematically difficult. Or even if you could do modeling, its generating in Simulink would be very tough. But in Signal Builder, you can do the process easily. As you can see, from the beginning, the block has a determined signal. It's like a pulse between 4 and 6 seconds. It's a default signal. We can change the signal. For example, I can change its amplitude. For example, you can change it like this. Also, you can change it with 1 or 4 seconds or any other changes that you want, you can do. This block has much more applications. In the top menu, you can access to many options that are related to this block. We have help, we have change time, we have enter maximum and minimum time. Here I let it 10 seconds. Here I can change the, also then you can set Y snap grid and Y display limit to change the displaying of Y axis. We can do it for time axis too. Here we can generate the new signals. I go to new constant here again, and here I can change the constant amplitude. You can add any number of signals, for example, add a square, and you can see that they added to outputs of block. Also here we have random noise. You can delete any of these signals. Also, we can change this color. And we can have some changes on line style or line width. And other changes that you can have on the signals of block. The other part which is interesting is custom. You can create any function here and use it in your simulation. Here I enter the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. For example, first, second, here I consider 5, 2 here, 3, 0, 1, 0, 2. So here I consider values for y corresponding to time values. So it creates such signals. You can create any signal by using this item. Additionally, you can hide the signals and show it again. We can rename the signal. You can replace it with another signal too. It was all about signal builder. As you understood, it is very applicative because it generates your desired signal. Let's have an example about this block. In this example, I want to have triangular signal and explain how to work with. I delete these signals. I begin from this 0 second. We enter in the y value section numbers corresponding to time values. For example, if you cannot enter 10 numbers in the time values and 11 numbers in the y value. Now I want to see the signal and take its integral to. I add integrator block to my new model scope. This is the signal which was in signal builder, a custom signal, but the bottom figure also shows integral of above signal. I don't save it. That's very simple. The other block is ramp. Here you can define a system which starts with an initial value. You can set its start time and also its slope here too. Here I want to give an example using the integrator and scope blocks. I add max to. I connect them to each other. I set slope 2, start time 1, and initial output 2. I run the system. The first one is ramp. The signal is ramp. It starts from 3, it's constant up to 1, and after first second it's increasing, and the purple signal is the integral of ramp signal. Let me give some explanations about sinus wave. By double clicking on the block, you can see its details and make some changes on it. As you can see, this is sinus wave output, amplitude times sinus frequency times t plus phase plus bias, which is specified DC amount, that show our sinus signal start from where. Let's see that what changes we can have. There are two options in time-based state, continuous. Here in sinus type we have time-based and sample-based. Also there are two options in time-based state, continuous and discrete. For discrete mode, if the sample time be greater than 0, our simulation type is discrete. For continuous mode, the sample time must be 0. In this course, we mostly use continuous because our sinus was time-based and we considered sample time in most of our simulations 0. Also, there are different parts of sinus: amplitude, bias, frequency, phase, sample time. Here, the phase is the phase shift that we want to apply on signal, and bias is DC value that enter the system at first. Okay, now I want to create a model with sinus wave block in order to know the differences of discrete, continuous, time-based, and sample-based better. I want a scope with 3 inputs. I set the first one in default mode. Second one, sample time, is 0.25 to be discrete, and for the third one, sign type is sample based and sample time is 0.25. Now I want to see the simulation of the 3 inputs. As you can see, the first one is a complete sinus function in the continuous form, and the third signal simulated is based on the sample time that we entered on this block, and it has discrete form. The only continuous state was for the first signal, that its sample time value was 0. So you can create any signal, sinus signal, like discrete or continuous in your simulation. The other block is repeating sequence. I added to my new model. This block gives us a periodic function in output. We can use this block, that is a source block, when we want to have periodic wave. We have this feature in signal builder, which you could enter the amounts in a specific time interval. I connect them to each other. In the first block I accept the default values, and in the second block I want to consider 3 different times. And as you can see, the first function was between 0 to 2, and its output must be 0 at 2 seconds. The reason is that the simulation time is 10 seconds, and we only have defined it between 0 to 2 seconds in block. The Simulink repeat this signal, which we have defined it from 0 to 2 seconds for the other 2 seconds intervals, and as you can see, its shape is not very good. Here simulation has been done better because we defined the values with more accuracy. It has the same function as repeating sequence. You can define periodic functions by this block. The other block is chip signal, that I think it is very interesting because it generates a sinus wave in the output, which its frequency is increasing in a linear form along the simulation time. You can click on the block and see its details. We have initial frequency, target time, and frequency again. And frequency at target time. I want to show that how will be the output. I use integrator block tool. As you can see, we have sinus function with its frequency changing constantly. It has an interesting waveform. Okay, now I want to talk about random. We have two random blocks. One is uniform random number and the other one is random number. I add them into my new model. We can see their simulation results in the output block. Here, just I want to show a simple simulation of these two blocks. For these functions that are variable, display shows the final amount of signal. For random signals, I think the simple simulation that we have here is sufficient. We can see the minimum and maximum values for this block, that between these two values or random signals can be defined. Also, we have sit here. In random number also we have a mean, variance. We have sample time 0.25 like as the previous one. As you can see, it is changing between -1 and 1. It's a random. In the below graph we have these two. It begins from 1. As we saw in signal generator, we could generate a random signal with signal generator block 2. The next block is band limited white noise. This block generated limited white noise. Look at here, look at this slide. You can see the amplitude, phase delay, pulse width, and period. So you can insert the amounts of pulse generator block using this by looking at this shape. And noise has a constant power which defines between positive and negative infinities. In practice, there are many ways to limit the noise to have a power in a specific interval. This block is useful in filters section. Now I want to show you an example about it too. We enter its amount. Okay, now for our example, suppose an RC low pass filter. It has a resistance and capacitor. Here we want to enter the white noise by this N and see the output. The transfer function of this filter circuit is like this. It's R plus 1 divides SC, which here C equals 1 microfarad and R equals 1 mega ohm. The final transformation function will be 1 on S plus 1, which is first order filter. I show it in the Simulink and set its input band limited white noise with default values. So we should add the transfer function for its generation. And also scope for output. Max, here you can see the outputs. We connect them to each other. As you can see, the filter has limited the white noise signal. It's changing based on the performance of filter. And it was an example about band limiter noise. I don't save it because that's very simple. The next block is repeating a sequence step. This block generates a sectional discrete function. It repeats what is interned in it and specifies their location by sample time. We set the simulation time 10 seconds. I enter the inputs. I also add the scope block. You can see the output here. Because the sample time was 0.5 seconds, so the pulse amount is changing each 0.5 seconds. First 0.5 seconds was minus 4 based on the what we defined in the block. This function is repeating during the simulation time. The other block is counter free running. It has many applications. The block gives us 2 to the power n minus 1 in the output. When it has reached to the amount, this amount, the output will be 0 and repeats the process. Now, as you can see, it is increasing in stair shape, the function, because I entered 5, so 2 to the power 5 is 32 and minus 1 is 31. After reach the amount, the function becomes 0 and repeats the process. Here, because our simulation ends at 18, so display shows up to here. Here I just wanted to explain the most important applicated blocks, those which are tough. But if you have any problem with these simple blocks, you can use help and see its applications and how to work with.